Hi everyone, and welcome to How to Network Presents Python. In this course we'll be going through the Microsoft certification named 98381. I'll show you the Microsoft page later on in this video. So this is chapter 1, lesson 1, and I'm just going to introduce myself. I'm going to introduce a bit of what we'll be going through across the whole course, and then we'll get right into it in the next few videos. So a little bit about me to start with. I'm Daniel. I've been using Python for almost a decade. I started with Python 2. In this module we'll be going through Python 3, and basically everything these days is Python 3. There's only a few differences that you'll need to be aware of, and I'll point these out to you as we go along in the course. So basically I've done scripts for large companies in the UK. So, for example, where we had to have two services talking to each other, it's quite difficult a few years ago. These days it's a little easier, but a few years ago we just create a Python script to talk to two APIs and get them talking to each other. Also, these days a lot of websites use an API backend. That is mostly done in, backend languages like Python. So, these days Python's kind of coming up on websites as well. So, what you'll learn. In Module 1, we'll just be going through some basic Python syntax. We'll be going through the differences between an integer, a string, and some other variable types as well. We'll be going through assigning variables and constants. And we'll also be going through how to use the keywords is and in. And we'll be determining the sequence of operations, and I'll show you what that means now on the Microsoft page. So, as you can see here, we have the Microsoft exam 98381 and basically Introduction to Programming Using Python. So, if we go down here, and you'll probably notice a familiar form. So, that's the structure of the course right there, and we will be referring to this page a lot, and at the start of each module I'll basically give you this, and then at the end I'll say how we've gone through it. Okay, so what you'll need, we're going to go through this with Visual Studio Code, but you are free to use whatever IDE you like if you're more familiar with another, but it's best to get acquainted with Visual Studio Code because you're preparing for a Microsoft exam and they generally come at you from their own software. Although Python is IDE agnostic, you might get some questions that will just throw you off a little bit if you're not familiar with VS Code. You'll need Python, of course, and we'll just be using the latest one. So I'll show you now how we can get Python and VS Code. So as you can see here, we just go to python.org, and again we're in Windows. Linux is a whole different thing. You're probably best following in Windows on this one, as it's a Microsoft course. So basically you just come down here and go download latest Python, just click that. And it'll then give you the latest release, third maintenance release, yada yada yada. And then we scroll down here and here are the files. So all you need to do is just download the executable installer here, save the file, and I don't know where we're in Firefox, that's why. There we go, and as you can see it's downloading very, very slowly on my computer. So the other thing you're going to need is Visual Studio Code, which is right here. And you just go to code.visualstudio.com, and then we just download for Windows Stable Build. And that should just immediately start downloading. Oh, yeah. Yes, it does. It does immediately start. It's just my computer. Okay, so because I've already got these, just put them in your downloads, install VS Code, and then all you need to do to start VS Code is just open it like that. And there we go. And then you've just got to install Python from the download you did earlier as well. As you can see, we just install it here. It just does tell me to modify because I've already got it, but for you guys, just go through and install it normally and it'll be fine. Cancel that. Okay, so now we've got VS Code. There's one final thing that we need to get, and it's just a Python extension. So basically, you're down here to this little blocky thing with a block off, and then you just search Python. And it's the first one because it's a Microsoft, as you can see, Python by Microsoft. So for you, there'll just be an install button here. For me, is a reload required. So yeah, and that's it. That's the Python module installed and VS Code ready to go. Just to test, you can open a very quick folder. Hang on, just create a new folder in here. Select that. There we go. And then just create a file called test.py. And as you can see, it'll activate. Yes, there we go. It'll activate the Python 3.8.2 down there as well. So when that's down there, it means everything's fine and everything's ready and running. So then if we just do the print hello world, you know, just as is tradition, we can start debugging that. And there we go, we get hello world out there. Okay, so the format of the rest of these videos. Generally, we'll have 2 or 3 theory lessons per module, plus a review at the end of each module. We'll go through what I've taught and we'll go through what Microsoft wants me to teach. We'll have some practical lessons with VS Code as well. And helpful links and commands should be provided somewhere below the video. Feel free to just sit and watch through and refer to areas that you need later on. Okay, thank you guys for watching, and I hope to see you in lesson 2. Bye bye. Hi everyone, and welcome to chapter 1 lesson 2. In this lesson we're going to go through 3 of the data types in Python. Before that, I'll just show you very briefly some stuff in VS Code that we can do with Python very easily. And I'll also point out some of the areas in the exam that you may need to do some extra studying on, because they will always try and trick you out here. So I'll obviously point out some areas, and in some places you're going to have to think, like, how do these variable types go together when you wouldn't normally do it in real life. So I'll definitely point those out, and you guys can take notes. So the first thing I'm going to go through is variables and functions. So a variable is basically just as it sounds. It's a point where we can put variable data. For example, a score in a game, it'll frequently change. We just put it in a variable somewhere and change it as needed. A function is something that we can call in the program with variables or without if we want, and we can start any function with the keyword def. Now, the reason we use functions is because we can then reuse code over and over without having to type it 5 times. So I'm going to show you guys a really simple example in VS Code here. And as you can see, we have our add2 function. So this doesn't run until it's called down here. So we got the add2 function and we send in a variable of a, and then b equals a plus 2, and it will return b. And then it will print it here. So the first line it will run is actually line 6. So it'll print add2 to 2 and then stop. So if I go ahead and run this for you guys, as you can see, it prints 4 and it prints 5 because it's run the add2 function twice. So if I get rid of that now, yeah, okay, got rid of that. We start again. Let me just do that one more time. So now it only prints 4. So it prints because we've got the print here. If we get rid of this print and just do the add2, it'll do the add2, but it won't print it. So show you guys that. As you can see, nothing was printed down here that time because we don't print it. We return it and then we do nothing with it pretty much. But we can actually print it in here as well. So if we print b, nope, hang on, sorry. Print b there, okay. I was doing it in the Python 2 way. This is a Python 3 course. So let's do it in the Python 3 way. And as you can see, it prints 4 again there because we're printing b out here, which is already then added. Now, something to remember is that any variables in here are actually local to this function. So if we try and print b down here, it'll actually bring us an error. As you can see, error b here is not defined. b here is defined and it printed it. So basically just remember anything in a function is always local to that function. And the reason for that is if we call add2 5 times, we're going to have 5 different b's and we're not going to know which and where it is. So that's why that's the case there. I know we're going into this quite quickly, and just feel free to rewatch and we'll go from there. So as you can see, each function has its own local variable and we can run a function as many times as is needed. So a little bit more about Python in general. It's a dynamically typed language. This means everything is handled during runtime. For example, the variables and everything else, we don't have to define them before we run it. We can assign new variables and functions easily wherever we are in the program. We can even use a debugger and add a new function like that while the program is running. Python will take a best guess as to what data type your variable is. So as you can see here, we just said add2 2. Now it knows that's an integer. I'm going to get rid of that print there and get rid of that. So it knows it's an integer already. It's just going to take a guess. Oh, this is an integer. If we did it like with quotes, like that, it would then guess that it was a string. So a little bit more about strings while we're here. You can think of strings in Python just as words. We can assign a string with either a equals, and then remember the quotations hello, or a equals if we definitely want it to be a string, as in we don't want any ambiguity here. We can use str and then hello, and that would make it a definite string. Note that quotes here are very important, otherwise Python will think you're referencing a variable called hello. So let me show you guys that. So if we print here hello, the string, and then we run that. Oh, I forget I can just use F5 sometimes. So as you can see, it just prints hello there, and it is a string. And I'll show you guys how in later lessons to know for sure that is a string. Now if we print it without the quotations, it'll think that you're referring to a hello variable, and it will basically say hello is not defined. So now for a little bit about integers. Integers are whole numbers that do not have a decimal. So 3 and 5 are integers, but 5.6 is not because it has a decimal and it's a partial number basically. We can do normal arithmetic using plus, minus, multiplication, division. We can do all that. And we can also use double arithmetic signs for division and multiplication. So a double multiplication is actually to the power of. So e.g. 5 double and then 2 would be 25 because it's basically 5 to the power of 2, which is 25. And double division basically tells Python to remove the remainder. So let me show you guys a quick example of that. As you can see, we've still got this function here, but we're not actually calling it anymore, so it doesn't actually bother us or do anything. So let me print for you guys to, let me think, 10 divided by 4. There we go. And let me run that. There we go. So as you can see, it just prints 2. It doesn't print 2 point whatever. It prints 2. Now, if we do a normal division with just 1, it'll print 2.5. Which is obviously the correct answer. Now, this is a decimal, so it's not an integer, whereas the one before, the 2, is an integer. So plus plus and minus minus are simply plus and minus. You don't need to worry about these. If they do come up in the exam, just think of them as plus and minus. There's no difference. Because the exam will try and trick you out with those, I guarantee it. So, Boolean. Sorry about that. Boolean. Boolean can be thought of as true and false. An empty variable is always false. An integer with a value of 0 is also false. So anything that's empty is false by default. Note that if you're using true and false, the first letter must be capitalized. Otherwise, Python will just not be happy. And if you see quotes, it's actually a string. So true. Hang on, let me show you guys. So bool and then quotation false is actually true because there is a string in there of false, but it is a string, so it'll come out as true. I hope that makes sense, because this will come up in the exam as well. So a quick note on quotations as well, and this might get a little messy. You can use both double and single quotations in Python to define a string. So single quote hello is the same as double quote hello, and they're both strings. So, and this is PowerPoint messing the format up here. So we've got a double quote, two single quotes, and then a double quote. So it's a set of single quotes wrapped in a double quote, and it's actually a valid string in Python. So probably easier for me to show you guys here, to be honest. So if I do a double quote, and then single quote, and as you can see, there it is. So if we then run that, there we go, as you can see, it prints out a single quote there. And we can do it the other way as well. Now, the one thing to note as well is if we print a Boolean type, so we ask, what is this in Boolean? Let's have a look what it says. There we go. It's actually true because there is something within that quote. It looks like it's false. It looks like there's nothing there, but these are actually a string, so it's true. Hello world, as in double quote, single quote, is also a perfectly valid string, and it will print with the single quotes. And the other way as well will print with the double quotes. Okay, so thank you guys for watching that, and I hope that was a very short introduction to Python. I'm trying to kind of keep things, modulated and go on like that. If you guys have any trouble, just keep watching and rewatch, and there's also Google and stuff, and then at the end there'll be some revision and question materials as well. Thank you very much. Hi everyone, and welcome to Chapter 1 Lesson 3. In this lesson we're going to go through manipulating some data in Python, and we're going to go through a few more data types as well. So one of the things I wanted to go through with you guys was the Modulo function in Python. It's represented by a % symbol, and it simply means divide these two numbers and then give us the remainder. This will come up quite a bit in the exam as well, so they do try and catch you out with this, so do remember this. So 10 modulo 5 is 0 because there is no remainder, and 11 modulo 5 is 1 because of the remainder of 1. So next thing we're going to go through is lists, and again at the end we'll go through all this in the actual VS Code, no problem. A list is an ordered array represented by square brackets. So for example, this is a list right here, starting at 0 and going to 5. So there's actually 6 different items. To call the number 1, as in the literal, you'd use A1, which would then give you 1. All lists in Python start at 0, and you can store all kinds of different variables as well. They don't all have to be an integer or a Boolean or a string. You can store them all in there just fine. So for example, B is 8, 10 and then hello here. This is a 3 item list. B0 would be the integer 8 and B2 would be the string hello. And just remember the square brackets here, they are important because they will really try and trip you up. So a bit of a continuation. You can also get a subset of a list, and this is important. We'll go through ways to do this in strings in a minute as well. So you can get a subset of a list with 3 and 4. For example, this would get you items 3 and 4. In this case, it would give us the 3rd and 4th item of list A. So you can think of it as start-stop, basically. A without the start or without the stop, it gets us from the start or from the end. So for example, 4 and then nothing would get us from the 5th to the end, because it starts at 0, remember? And 2 would get us from the start to the 3rd. Remember, all lists do start at 0. So, a bit about identity, or is, in Python. It's quite simple. It'll just compare two things and give us a Boolean on whether they're the same. So it's true or false. It'll also compare data types. So a string with the content 100 is not the same as the actual integer 100. We should only use is to compare variables. To compare literals, we should just use equals equals or exclamation mark equals instead. And basically not equal to and equal to. So this print 100 equals 100 would actually give us true. So a bit about in. In will look for a specific query inside something. So it's basically like saying to Python, hey, is this in here? So print 7 in LST would search a list called LST for the number 7 and then again print true or false. The Python way of using is and in looks something like this. So if 7 in LST and then print hello. So if it's there, print hello. And then if 100 is 100, of course it is, it'll print 100 is definitely equal to 100. So just a little bit about splitting strings as well, just a few points here. We can split strings using the same thing we use to split lists. So print hello world 2 would actually give us the letter L, because L is in the third place, 0, 1, 2. Print hello world 1 and then to the end, it would just start here. So because we've got a 1 and not a 0, it would get rid of the H at the start and it will give us hello world. Okay, so let me briefly go on to here. As you can see, I've prepared a little bit. So the first thing it's going to do is print a Boolean of true or false. It'll also decide whether A is B. And as you can see here, A is an integer, B is a string of 100. So A shouldn't be B, so this should be false. It'll then print if A, it'll print A is true. If C, it'll print C is true. And basically this if is deciding whether it's true or false. So if it's just saying if A is true, like that. Oh, sorry, true. That is basically what that's saying in longer terms. But in Python, we can just say if A. That's quite easy as well. So then we've got the list here, a very long list. It'll print us the second, or 1, which is actually 2 here. And then it'll print 1 to the end, which should print everything except 7. And then if 7's in LST, it'll print us 7 is here. And then finally, we've got the test string. We say, is H in there? Is Z in there? And then we print the E here as well. So that was a lot to take in, but let's see if our little code here works. So we're going to run it. And as you can see, it's printed us a lot. True, false, A is true. So then we're down here. So this is the true one. This is the false one. And then A is true. C is not true because it didn't print this. It'll print the list. It'll print the 2 and then the list without the 7. As you can see, we ask is 7 in the list. 7 is here. And then true, false, and finally E from hello world. So yeah, that was that was quite a bit to take in. We could actually modify this a little as well. So something that I wanted to go through with you guys, and I'm just going to delete some of this for now. There's a way to work out what I'll just delete all of it for now. So b equals 100, as you can see, and then we run this code here, and doesn't output anything. So then b equals, sorry, hang on. So then we can print the type of b, and this will show us whether it's definitely an integer or definitely a string or whatever. And as you can see, Python does like to do this, the brackets in the brackets in the brackets. Python really likes to do this. In some larger programs I've dealt with, we deal with 5 of these brackets and brackets things. So just be wary of that as well. So if we now start debugging, as you can see, class integer. So we know this is definitely an integer now. We can also do this, which makes it a string, and then true. So b is true there, and that will print us a Boolean because it's a Boolean. Okay, thank you so much for watching that, guys, and I will see you in the next lesson. In the next lesson, we're going to go through actually converting between strings and integers and all the rest of it. And we're also going to go through the floats or decimals in Python as well. And finally, we're going to go through the order of arithmetic. Now, for some reason, this exam really likes to test you on that. It's not really Pythonic, it's more mathematics, but it really likes to test you, so we'll be going through a bit of that as well. Okay, take care, bye-bye. Hi everyone, and welcome to Chapter 1, Lesson 4. In this lesson, it's going to be more of a generic order of operations lesson with a little bit of Python at the end. That's because this exam really does tend to push this quite heavily, even though mostly in the real world we just Google it. So just remember the order of operations. It's quite important for some reason. I really like it. So a bit about it. It's something that will frequently come up. It's pretty much based off mathematics, you know, it's the same in any programming language, and if you remember at school in maths you probably had a, what's it called, an acronym for it. It can broadly be represented by PEMDAS or whatever acronym you guys use. That is basically parenthesis first, then anything inside the parenthesis obviously, exponents, so basically anything to the power of. Then we go for multiplication and division, and these are on the same level. And then addition and subtraction also on the same level. So you basically have 3 different levels here. You have the parenthesis, the exponents on one level, multiplication, division on the other, addition and subtraction on the other. And I'm just going to go through a couple of examples with you right now. Yes, so for order of operations of the same precedence, as in you've got 2 multiplications or 2 divisions, you'll basically read it from left to right. So like you would in English. So some examples. So 8 plus 6 minus 9 is 5. That's because we basically add the 8 to 6 and then minus 9 and it's 5. So nice and easy. In this case, 9 minus 8 is 1, and then plus 6, and that's just going to be 7. So again, we're only doing it from left to right here. Nice and easy. So now we've got a couple of parentheses in the mix. So as you know, these come first. So anything in the brackets, so we add the 8 and 6 first, which is 14. And then, so it's 9 minus 14, so it's minus 5. And then 9 times 5 plus 5 is of course 50, because we do the multiplication first. Even if the multiplication was over here and it was 5 plus 9 times 5, it would still be 50. So here we have another multiplication, but because we've got parenthesis, we do the parenthesis first. So this is 10, and then we times it in 10 by 9, so it's obviously 90. Now, to the power of comes first, because we do exponents first here, so 9 to the power of 2, and that is, I believe, 81, and then plus 9, because that's on a lower level, and we get 90 again. Now, this one's important, so if you remember last time, the double slashes and the single slashes, so a double slash is basically just get rid of the remainder, just have the integer number. And a single slash, we will use the remainder as well. So again, 9 to the power of 2 divided by 9 is just going to be 9. And this is a very complicated one right here, but as I say, we just do the parenthesis first and we do them left to right. So we do, this one is 12, this one is 36, and then 5 divided by 2 is of course 2.5, I believe, but we have the double slash here, so it is just 2. So we just get rid of the remainder completely. So now we know we've got 12, 36 and 2, and 2 times 70 is 70 something. Very complicated. Hang on 1 second. 2 times 70, yes, 140. And then we're just going to add all these up as well, so it's basically addition from there on. And remember, we're going from this side to this side. Mathematics, not really my strong point, but yes. So others to add as well. Strings can also be added together. So h plus low is hlow, and this will come out as a string as well. But you can't convert a string character to an integer. So if we try that, it's just not going to work at all. As well as Boolean, we can also add Boolean. If the exam asks for a Boolean answer and there's anything in there, it's true. So if it asks you, for example, let me pull up Python here for you guys. So if it asks you, hang on, clear that first. So if it asks you bool, for example 5, that's just going to be 1 or true, but then we can convert it to an integer just using int there as well. So true plus true is 2, strangely enough. So there's also or and and. Or and can be used as Boolean operators. So true and true is true, or 1, because both inputs are true. And you can think of true and false as just 0 and 1. It's basically a subtype of the integer anyway, so it is just 0 and 1. It just represents itself as true. So true and false, obviously false, because it's basically saying, are these two true? That's what the and is saying. Is this and this true? No, it's not, so it's false. So true or false is true, because one of these is true with the or. So just or is basically 1, and is basically both. So 5 and true is true, and then obviously that's 1 in an integer as well. That's 1. False is 0. So a bit about length and floats. So len in Python can basically give you the length of a string. So len hello is 5. The output will be an integer type. A float is a data type we haven't really been through yet, but they don't touch on this too much in the exam, but they will expect you to know what it is. So it's a decimal number, so 4.5 is a float. You can add a float to an integer, but you'll get a float in return, unless you're using the double slashes. And one other thing to remember, it doesn't do any rounding. So if your answer is 1.99 and you're using the double slashes, you'll just get 1. That whole 0.99 will go away. So a bit about find and rfind, as these come up as well. We can use find and rfind on a string, and only a string. We can't use this on integers or lists or any of that. Find will return the first occurrence of what you're looking for. Rfind return the last occurrence, basically a right find, so it'll start at the right instead of the left. So for example, we've got a equals hello world right here. So a.find L will return you a 2, because we start at 0, so 0, 1, 2. And it'll only return you the first one. It's not going to return you any more. So for example, you've got 2 more in here, but you're not going to know this by using a find. Rfind on L is 9, because it will start over here, and then it will find it here, and that is the 9th character. Well, it's the 10th, but it's the 9th in Python. Find and rfind take an optional extra parameter for the start character, so a.find L5 would be 9 because it will skip over these, because it will start at this space here. 0, 1, 2, 3, 4, 5. As you can see, the space also counts. So something to remember as well in the exam, they will make you use len, and they'll probably ask you to count 46 different characters. One thing they do like to do is the whole quotations thing. So they like to basically trick you into not seeing quotations are there because you've got single quotes in double quotes. So just remember, any quotations that are the opposite type inside a string is going to be counted towards that string. So a bit more about strings while we're on it. Starting a string with 3 quotations or 3 single quotations will allow you to make the string over multiple lines without worrying about line breaks. And something else to remember, because they will really try and trip you up on this as well, 5 plus 5 is 55 if you've got strings instead of integers. So if you've got quotations around them, just basically splice them together like that rather than actually adding them mathematically. Adding a string to an integer is not possible. It'll give you an error. Let me just show you that very briefly. So if we 5 plus 5, there you go, unsupported operand type for int and string. So basically it will not add an integer and a string. Adding a bool or float to an integer is fine, of course, because the Boolean is basically a subtype of an integer anyway, and a float is a number. So you've got to be able to add them together. Okay guys, thank you very much for watching that, and that will conclude Module 1. I'm sure there'll be a test somewhere later on. So see you in Module 2, and we'll be going through the next stuff for the exam. Bye bye. Hi everyone, and welcome to Chapter 2, Lesson 1. I hope you all went through the practice exam. I made it as close to the real thing as I could, and the real thing is a little bit difficult and trips you up, so don't be disappointed if you didn't manage to get it. Just see where you went wrong and redo it, and we'll have a practice exam at the end of each module as well. So on to conversions and if statements. We covered this in Chapter 1 a little bit, but we'll just be covering conversions very quickly and then going on to if statements and what they are and how we can use them. So a bit about conversions first. We can convert a variable to other types, as I'm sure you all know. Just remember, some of it is common sense, and you cannot convert a string to an integer, as much as you want to try. You can convert an integer to a string though, that's fine. So we've got a equals 5, and then float a or boolean a would work, and string a would not. So you can do a equals string a, which would then overwrite a with a string, for example, as well. That's fine. And let me just show you guys that real quick. I'll just ignore the if stuff up there for now. Just pay attention down here instead, and then Python. So if we do a equals 5, and then a equals string of a, and now we print the type of a, and now it's a string rather than an integer. That's basically what I meant there. Okay, so now we're going to go on to if statements. So it's one of a programming language's basic things. Comes up in every single programming language almost. I haven't seen a programming language without an if statement yet, except some very obscure ones. As I say, it appears in almost all of them. We went through a little of it in Chapter 1, and it's basically just as it sounds. So if x is y, then do this. For numerical comparisons, you need to use equals equals instead of is. So it actually does work either way. In Python 3.8, they are trying to discourage using either way and trying to make you use the correct one, so they'll bring up a syntax error. But yeah, you should probably use them properly, especially if you're going for an exam. So if x equals y, oh, sorry, yep. So let me just show you guys a quick example of that. And now we'll look up here. So as you can see, we've got a equals 5, b equals 8, and then we've got a very basic if statement here, if a plus b is 13. And we can do arithmetic within the if statement. That's what I was trying to show you here. So if we just exit this string stuff we were doing earlier, and then I run this for you, we'll basically get, yay, the maths works. And if that didn't print, then a plus b is not 13. So if we make a plus b 14 instead, it now won't print anything because it's not executing the stuff in the if statement here. So on to else. If and else are used together, or can be used together, you don't need to. In pseudocode, it would basically be if x is y, do this, else do that. So do this or do that, basically. And if and else it's more like an or, in that they will return either one but not both, depending on the original if statement. So it'll do this or it'll do that. It won't do both. You can run any code you like inside the if and else statements, but be aware they might not run if your if's not. Right. Okay, a little bit about Elif as well. Elif stands for else if, so you don't have multiple ifs. Like, you can't say if this is this, if that is that, if something is something. You have if this is this, elif is that that, if you get what I mean. So rather than finality of else, which will run without conditions, the if statement is false. So elif is the middle ground. Pseudocode again. If x is y, do this. Elif x is z, do something else. Else do that. So if this isn't true and this isn't true, it'll finally do the else. If one of these is true, it will not run the else. So let me just show you guys a couple of examples I mocked up earlier here in else. So as you can see, we've done the a plus b again. If it's 10, the maths works. Else, oops. So if we run that now, there you go, the maths works. And then if we change b to 6 again, save that and run, we should get oops out. Yep, we get oops out instead. So it'll run either one. It won't run both. So you can nest ifs as well. Probably better to show you this again rather than do it in pseudocode, because this can be a little complicated. So if we go to nested py up here, as you can see, we've got a, b and c. We're actually not using b, so I'm going to get rid of b. We've got a and c here. So if a is 5, if c is 8, then we print here's some code. And right now a is 5 and c is 8, so we should print this here. And this would be the only thing that prints, or should be. Let me clear that out of that and then run it again for you guys. Yeah, so we get here's some code. And then that runs if c equals 8. So if we change c to 9 now, we should get this code shouldn't run because a is still 5, so it will still go into here. C is not 8, so it will go straight down to the else and then print this out here. And then because a is 5, it's not going to run this elif, and it's not going to run the else. So there we go, this code shouldn't run, which I imagine a lot of people have in development, code that should not run. So there we go, we've got that. So now we're going to change a to 6. And now, none of this here will run, because a is not 5. None of this block will run at all. So we won't get this code shouldn't run, even though c is not 8, because a is not 5. And this is basically what a nested if statement is. And it can go down on an unlimited way, so you could have 10 of these. As bad of an idea as that would be, and there's probably something else you could use, you could have 10 of these. So as you can see, we didn't touch the last code block at all. It's printing this here, and it hasn't touched this bit at all because A is not 5. A is 6. And then if we change A to 7, we'll get it was none of the above right here, because A is not 5, so we can get rid of that. A is not 6, so we can get rid of that, and then we finally drop into the else here at the end. And obviously if A is 5 or if A equals 6, it'll run this code instead and not the else. Hope that made sense. So how do ifs work? Ifs use a Boolean to either be true or false. So we can shorten it if we're just saying does this thing exist to if A. So that basically says is A true, is A false. So if I just start, we'll go back to test py here, and then we'll say if A, we know A exists, print hello, there we go. So then we'll run that, and we get hello out there because A is true, it does exist, and that's just a true or false check. Okay, thank you guys for watching that. I hope that's clarified a little bit on the if, else and elif statements. Just remember you can't have multiple ifs, it then goes on to elif. So if, elif, 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 else. And then a finally at the end, which we'll go through in later lessons as well. Okay, thank you very much and take care, bye bye. Hi everyone and welcome to chapter 2, lesson 2. In this lesson we're going to go through more ifs and touch on for loops and while loops. So a bit more about ifs because I've done the exam and it is particularly horrid. So something to remember about an if is it will always have a colon after it, otherwise it will cause a syntax error. And what the exam can do is they can give you 2 correct answers but 1 without the colon. So you've really got to pay attention to this. So as you can see, this colon here basically means that has to be there, otherwise syntax error. So, and the line underneath will always be indented as well. And that's a thing in Python, you have to indent, otherwise you will have a syntax error as well. The exam, as I say, loves to throw if-else statements that won't actually run, so do keep an eye on that as well. They'll use things from the last module, for example types. They'll say if type equals int, then run this. But they'll also say if type is a list, then run this, but obviously you're not going through a list, so you won't actually run that code. So do try to keep an eye on that. So a little bit more. Greater than and less than are also particularly loved for this module. There's 4 to remember. These are the first 2, this one and this one. I'm sure you've seen them before. So this one means the value to the right of the value to the right is larger, and this one means the value to the left is larger. So you can think of the symbols, and this is how I always thought about it since primary school. You can think of the symbols as crocodiles. They always eat the larger integer, so that's always what it's asking. So you don't get confused between which one's which. So just as an example, if A is less than 5, so it's asking if A is smaller because the crocodile is pointing towards the 5, that's the bigger one. So it's asking is A smaller. It's a little bit backwards in that way, but you do get used to it eventually. Just keep practicing these. So the other ones, as I say, we've only gone through 2. The other ones are the or equal to. So we've been through greater than and less than, but there's also greater than and less than or equal to, which is simply with an equal sign after it. Just remember the equal sign will always come second, not first. I mean, you can see these are kind of faces, if you like to remember it like that as well. Just the other way, you know, from a normal smiley. So you can think of it like that, sad face and happy face. So 13 is less than or equal to 11. Hang on. As you can see, this confuses me as well. It's asking if the right integer is larger. In this case, it would be false. So 13 is less than or large or equal to 13 is asking if the right integer is larger or equal to. In this case, it would be true because they are equal. A while loop basically says while the following expression is true. And 1 second while I show you guys some examples of the while loop here. So let me get that centered. There we go. So as you can see, this is a basic while loop. X is 5. While x is less than 10, print hello, x is currently. And then as you can see, if we put x in there directly, x is an integer, this is a string, so it will bring a syntax error. So we just wrap it with string, and then it will make the number a string as well. Now, the thing to remember is this is like a temporary variable. So basically this doesn't change x at all. In order to change x, you'd have to do x equals string x. But we don't want to do that because then we need to keep it in the while loop. So we can just do it like that without actually assigning a variable to the string of x. We can just do it like this. And Python likes to do this a lot as well. And then down here we obviously add 1, and it'll just keep looping until x is 10 or 9 in this case. So let me start debugging that. There we go. As you can see, x is currently 5, so we've started at 5, and then it'll up it by 1, x is 6, x is 7, 8, 9. And then when it gets to 10, it'll say x is now greater than 10, sorry, x is now greater than 9, and then it will say, it'll basically skip this while loop and continue with the code after that. You can get stuck in infinite loops quite easily using while loops, so use them carefully in more complex programs. For example, if you don't do the incrementation, or if you put an if by the incrementation somewhere and it doesn't actually increment, then you'll just get stuck in the while loop forever. And I'll show you an example of that very soon. So for loops. A for loop is similar to the while loop, but it will go through a specific past variable. For example, a string or a list. You can't use a for loop with an integer. Just remember that. So we've got a simple list here, 5, 7, and 1. You can use a for loop like this. So for x in a. So x is then a new variable, and it'll loop the code 3 times, as there are 3 items. And x is the value of each iteration. So in this case, x will be 5, and then 7, and then 1. And it'll iterate like that through the whole list. So break can be used to jump out of a while or for loop early. Continue will jump out of that specific iteration of the loop, but continue looping. So I'm going to show you an example of these two, because they're a little difficult to get your head around. So as you can see, we've got a break here. So it's the same code as the while loop, but it's if x is 8, then break. So, and now we've got less than 12 for x as well. So it should go up to 11, but because of this, it'll actually break at 8. So let me show you guys. As you can see, we're running here, and the last one we run is 8, because it prints it, and then it'll say, oh, it's 8, and break, and then it'll just break and continue. It won't go through the rest. Now the continue, and this is going to be the infinite loop as well. I'm wondering if you guys can see this. So let me just clear this out of here. So if we run this now, as you can see, 5, 6, 7, and then it'll hang. It'll infinitely loop here. And the reason for this is because we're doing the while loop. We're saying if it's 8, which it wasn't for 5 or 6 or 7, so it won't do any of that. It'll just continue. It'll print, hello, x is currently 5, 6, or 7, and then it'll increment it by 1. But if it is 8, it'll just continue. So it'll just run this over and over again without ever incrementing the value. It'll just run this. It won't print, it won't increment. So as you can see, just run it forever and ever and ever. You guys have to see and basically work your way around and identify. So now we'll go for the correct continue. And as you can see, all we've done, we've put the increment up here instead. but this means it'll actually print it as 6. It'll go from 6 instead of going from 5 because we've incremented it already. So it's just something to be aware of, you know, with either way. You can start at 4 if you need 5. So now it'll start at 6 because it's incremented it already and then continued. As you can see here, we have skipped to 8. We have not printed this for 8 because when it's 8, it'll just continue to 9. It won't actually print anything out there. It won't do anything below the continue. So as you can see, we've got 7 and we've got 9. Yeah, and as I say, there are traps, which I've shown you. Okay, thank you guys for watching, and I will see you next time, and we'll go through some more complicated ifs, and some nested ifs as well, and we'll introduce range to you guys, and then some of the more complicated exam questions. Okay, thank you very much, and see you next time. Bye. Hi everyone, and welcome to Chapter 2, Lesson 3. In this lesson, we're going to be going through some different types of arrays, because these may come up in the exam for this module, and we'll also be going through some of the more complicated questions in the exam as well. I'll be showing you what the exam might give you and how these questions may be given to you as well. So, a bit about the exam first. The exam may ask you to use if and in, as I described in the last lesson. Let me show you an example of a practice question. So here we have basically, this is going to be a typical question that you'll see. So you'll have something up here, say a city, we've got Guangzhou, you could have New York or, you know, wherever. I think it depends on where you are as to how these things are formatted. So then we've got if city here, and then this looks like a lot of code. It's 20 lines of code. But once you start breaking it down, you can see the city is Guangzhou, but it's not in Shanghai, Beijing or Shenzhen, so it's not going to execute this block of code at all. So then we go down to the next one with the Elif, and we see Wuhan, Nanjing, Hangzhou, it's not in there at all either, so then it has to drop down to the else. And the else basically says if the order total is higher than 400, it's free shipping, else it's paid shipping. So, as you can see, our order total here is 350. So if we go ahead and run this bit of code, as you can see, paid shipping because it's below 400. So if we set it to 400 here, 400 exactly, and we run it again, as you can see, it's still paid shipping because the order total is not above 400. It has to be 401, not 400, because we don't have the equals sign. So if we do a greater than or equal to instead 400, let's run that. As you can see, now we get free shipping because anything that's 400 or above 400 now gets free shipping. And then we can mess around here as needed as well. We could set it to Shanghai, for example. As you can see, if it says in Shanghai, if the order total is below 200, it's free, else it's paid. So here it should come out as paid. And as you can see, paid shipping down there. So if we switch that way instead, so now it's saying if the order total is larger than 200, we'll do free shipping to Shanghai, Beijing and Shenzhen. And this is the one it's going to go for. It's not going to run any of these anymore. It's not going to run this Elif. It's not going to run the else because it's running the code within the if. And as you can see, we've got free shipping now as well. So it'll give you a lot of questions like this. You've just got to think a little bit and work through it step by step and simplify it as much as you can. The exam may also use x equals x plus 1 or x plus equals 1 interchangeably to try to trick you. Don't worry, they are exactly the same. So just either one of these that you see, we'll just add 1 to x. This is just a shorter version of doing it. The important thing about these questions, as I said, is to simplify them. They look quite huge, you know, 20, 30 lines, but once you simplify them and get where you're running, there's maybe 5 lines that you actually need to pay attention to. And just a final one, because I didn't mention this before, input will allow you to input a value from the console. So if the exam's bringing you something .input, it means you're putting it in from the console, that's all. Not actually used in production environments that much these days, but still important to remember. So a little bit about multi-dimensional lists, and I'm surprised this came up in this module actually, but the practice tests seem to be wanting you to know this. So a list can be inside a list. So as you can see, we've got a multi-dimensional list here. We've got 1, 6, and then another list with 0, 9, and 8. So if you printed A2, which is this 0, 9, and 8 here, you'd get the list inside. You'd get this out, basically. So to get a value from the list within the list, what you'll need to do is just add another one of these on the end, like this. So A2, 1, and you'd get 9. So you're going A, you're going for 2, which is this list, and then you're going for 1, which is the 9, because 0 is 0, remember. 1 is 9, 2 is 8. So you're getting the 9 out, and that would just print you a basic 9. And again, strings, integers, you know, you can put anything in here that you like. So a little bit more about the plus equals. Plus equals can actually be used to append to strings as well. So for example, A is a lot of hashes here, or whatever you like to call them. A equals A plus hash. Actually, this should have a quotation mark around it, sorry. Or A plus equals, and then as you can see the quotation marks and the hash. Again, that should be just 1 or 2, not 1 and 2. Sorry, the formatting's gone a bit funny here. So I can show you that really quickly here though, in the actual code. So let me clear this. Yep, hang on, clear. And then Python. So A equals, and then, as you can see, 4 hashes. So A plus equals hash, and then print A. As you can see, we've now got 5 hashes there. That's all I was trying to explain with the PowerPoint there. As you can see, it would result in 5 hashes in A. So dictionaries also come up in this module. Dictionaries are basically key value pairs, and it's a type of array just like a list. They're represented with curly braces instead of the square brackets. So Z equals, as you can see, a curly brace here, A1, B2, C3. ZA would be 1. It would basically get the value out for you. You couldn't actually get A out because that's the key. You need to find it by the key. You can only get the value using these. And as I said, you can only call it from the key, not the value. The key is first and the value is second. So a little bit more about that here. We have basically a similar question came up in the exam as well. You have the elements here, and this is called a set. It's basically a list that doesn't move. So that's a list, this is a set, and we'll go through this in a later slide as well. But for now, just think of this as a list. So then you've got the items here, which is a dictionary, you've got a count, and then you've basically got the actual bit of code here. So generally what it'll want you to try and do is make a number that count can equal. And as you can see, as you start going through it, you can see for E in elem, so this is elem here, so for each element, for each one of these, it'll check if E, as in the element you've got, so for the first one it'll be 12, it will check if it's in items, and 12 is not in items, so that's fine. If it's there, it'll print it, and then it'll add it. So as you can see, this is, it'll print 2, it'll print 4, because these are the two that run if E in items, because 2 is there, and 4 is there, and there. So it'll run that. And then count just adds E. So it'll just add all these together, basically. So count is just 33. It's just these lot added together here. So if we change this instead to a continue, as you can see, it's now 27. So it's actually ignoring when it's 2 and when it's 4. So it's got rid of this one and it's got rid of this one, and then it just adds 12, 10 and 5 together to get 27, which is sort of, if it's asking you this kind of question, it will say, how do you make count 27? You basically just need to go through line by line and work out how to make count 27. And normally it'll give you this, and this bit will be blank here, and it'll give you a couple of options. You know, one continue, one being pass. Don't use pass for this, use continue, because pass will just get you out of this if here. Okay, so a bit about greater than and less than as well. You can combine a greater than and less than into one statement for efficiency of code and ease of reading. So you basically would do it like this. If 1000 is, so this is basically 1000 is the bottom, 2000 is the top. And so if loan is 1000, it'll run the code below here. If the loan is 2000, it'll run the code below here. And if it's in between, it'll run the code below as well. Anything outside that range, 950 or 2001, will not run the code. And that's basically all you need to know of that one. It would simply execute the code if the entered loan amount was within the range. The exam will try and combine the above with regular greater than and less than, and other if statements as well. So just keep an eye out for that. It's relatively simple once you get your mind around it, even though it looks a little complicated to begin with. Be aware of the difference between greater than and greater than or equal to, as we went through earlier as well. So a little bit more about sets as well, which we saw earlier. Sets are basically lists that cannot be modified. They're defined with the regular brackets instead of the square brackets. So now we've got the regular brackets, the square brackets, and the curly brackets. So curly brackets are a dictionary, square brackets are a list, and regular brackets are a set. And those are the three that you'll need to remember. Once defined, you cannot append or change them in any way. So it's much like a constant variable in any other language. You just can't append to it. You can't delete anything from it. It's just there. Other than this, they're very similar to lists and can be called in the same way. So you've got a simple set here, and then A0 is 6, and it's just exactly the same as you would a list as well. Okay, thank you guys for watching that, and that wraps up Module 2. In the next module, we'll be going through input and output and some file stuff as well. Thank you very much, and see you next time. Bye. Hi everyone, and welcome to Chapter 3, Lesson 1. In this lesson, we're going to go through a bit of file handling in Python, and how to do it, and a bit about the reading and writing modes as well. If any of you ever done C or C++, you'll have seen this before, and it's basically just calling those at the back end. So, there we go. File handling. File handling in Python is mostly done with the open command. There's no importing or anything, it's just literally open. And I'll show you an example of this later on. You can open in a variety of modes. Some modes will allow you to append, write or read as needed. Remember to always go with least privileges. For example, if you just need to read, you probably don't want to open it in a write mode. If you just need to write, you don't really want to open it in a read mode. And yeah, there's what I just said. So a bit about the modes. You pass the mode with the open command. The open command takes two arguments that you need to care about. It actually takes some more, and we'll go through these in the third video because they do sometimes come up. But usually they're intuitive and you can work out what's going on. But the exam does like to throw some odd some odd arguments at you that you might not see in real life. So the two arguments are open, and then you got hello.text, and it's opening in read mode here. Actually, the read mode bit isn't needed because it actually opens by default in read mode, so you could just do it as open hello.text. RB mode, so anything with B on the end is basically binary. So RB, WB and AB are for binary reading and writing. Just remember that if the exam asks you to read or write from a binary file, which it may do. R plus is again text, and it's reading and writing together. And you can obviously have RB plus, so all these things tend to go together. W is for writing and will overwrite the existing file. Just remember that, because if the exam asks you to write something and then read it, obviously everything that was in there is gone. W plus is the same, but it will actually allow you to read after you've written later on. You just need seek, which we will go through in a second. So a little bit about appending files, and I've also got a very nice table for you here as well that I've fetched off the internet. Sometimes you just want to append to the bottom of the file. This can be done with A, and if you then want to read back what you've appended, A plus, again AB as well for binary. And here's the what's the word? The table. So we've got read, which is R and R plus. W plus will allow you to read as well, and A plus will also allow you to read. We've got write after seek, so that basically means read and then write. As you can see, those will let you do it. Create and truncate, we've not actually been through yet, but basically W and W plus, as I say, it'll wipe the file. That's basically a truncation. Create is basically if the file's not there, will it create it for us? And W plus, A and A plus will do that as well. And as you can see, the position at the start and position at the end here as well. So some of the other methods you may come across. Once you've opened the file, you can actually use a few methods. f.seek will allow you to input a number and be taken to that place inside the file. So f.seek 0 will just put you back to the start of the file. This may come up, for example, you'd use f.seek 0 to go back to the start. After reading it, it might come up in the exam, so do take some notes. f.read will read the entire file into a variable. If you say h equals f.read, would then import the entire thing. And I'll show you how this all comes together in a minute. f.readlines can be used to loop through a file using a for loop to do something line by line. So for example, if you wanted a list and each item of the list had a line of the file, that can be done as well. So there's another way to open files as well. You can open a file using with to make the code a bit easier to read, and also you don't need the close methods and some other methods as well. So with open file name as file, and then under that you'd do data equals file.read, for example, and that's it, just 2 lines. We don't need to call an f.close. If we do it with this, we don't need to do this. Sorry, that's a tongue twister. We don't need to do this. It'll be done automatically. Okay, so let me just very briefly go through an example with you guys. So as you can see, we've got open hello.text. We open it in write mode, we write hi, and then we close it. Now here we don't actually have any variables or anything. And then we open it again as a file. Again, we don't have a mode, so it just opens it in read mode, and then it will just file read and print data out there. So if I now run that for you guys, there you go. As you can see, it's just printed hi, and then if we go into the files here, you can see hello.text with hi in it. Now if we run it again, as you can see, again, just one hi comes out there. But if we do it in append mode instead, and this is for the open bit, you'll then get hi hi. And as you can see, we get it like this because it's just writing them directly. If we use write lines instead, it'll write them on individual lines. There we go. So if we then run that, hi, and then hi at the bottom there. And then if we go into the hello.txt here, as you can see, it's here as well. Okay, thanks for watching, guys, and I hope you know a little bit more about reading and writing from files now. We'll go back to this in lesson 3 of this module. For the next one, we're going through formatting of strings. Thank you very much, and goodbye. Hi everyone, and welcome to chapter 3, lesson 2. In this lesson, we're going to be going through formatting strings, as I promised last lesson. So, string formatting. String formatting can be done basically with string.format, as you'd expect. And as you can see, we've got the string here, hello, and then some curly braces, and then dot format with world. And that'll basically print hello world, as in it'll put the world into those curly braces and get rid of the braces. So you can think of the braces as a placeholder. The older way to do it is with percent signs, which you may see here and there as well as you're looking through the internet. So it's basically very similar. You've just got %s, which is a string, %s again, and then 1, 2. So that'll basically print 1, 2 where these placeholders are. When the placeholder is empty, Python will go through the arguments given in order. So basically there's only one here, it'll just put world in there. And as you can see, we've got hello and then 1, 2, 3, 4. And then we've got 1, 2, 3, 4 in here, so it'll just print hello world, how are you? And that's the automatic way of doing it. There's also a manual way of doing it, which is we can give it a number. So, as you can see, we've got 4 here, but we've specified them all as 0. So this will literally just print hello world, 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 world. It won't use these because we've given them all a 0. Now, just something to know is that if you're giving like 3 a 0 and then 1 nothing, it'll actually throw an error. So you either give them all a number or you give none of them a number and let it do it automatically. You can't mix and match in one string. So a little bit more here. The curly brackets actually take 2 arguments. It's by default, it's just a string, so it's basically position conversion. So nothing %s would say use the next argument, as in do it automatically, and display it as a string. Now normally you wouldn't actually need the %s, sorry, the colon s there, because that's automatic. So in one string you can use either an automatic or manual numbering. Okay, let me just go back 1 second because I have some examples of this to show you guys. So as you can see here, we have basically 2 strings. Just bring that out there. There we go. We've got this one, and as you can see, this one just prints it directly. This one actually puts it into a variable and then prints it with the variable. So you can do it either way. If you want to do it on a variable and format it different ways and print it several times, you can definitely do it like that. Or if you just want to straight up print it out, you can do it like that as well. So as you can see, for this one, we're just doing a string and then nothing, nothing, nothing. So that will just print hello world, how are you? Simple. The next one will actually print hello world as a string. It will print how are you as a string, and then it'll also print 10 as a decimal. As you can see, we've got the D here and then the 2, which refers to this one. So again, it's just like an array, 0, 1, 2, 0, 1, 2. So let me run this for you. As you can see, we've got the 10 there printing out. We've got hello world, how are you? And then, so we've got both of these printing out just fine. The other one I wanted to show you guys is a float. So we can actually change that to a float as well. And as you can see, it'll just print 10.00000 with 6 decimal places. You can also change the decimal places as needed. I'll show you how to do that in probably the next lesson. But yes, that's that. So one other thing I need to show you guys is conversion table. So as you can see, we've got strings, decimals, floating point, and as you can see, we went from D to F. We've got characters, binary, octal, and hexadecimal with upper and lower. Now these three here I've not actually seen in the exam. That one I haven't seen either, but you may come across it, so just keep them in mind. OXXE, keep them in mind there. The main ones you're going to deal with are these 5 here, so that's fine. Now a little bit about datetime, because it's very similar in the way it formats, and this may come up in this part of the exam as well. It may ask you to import and use datetime and choose the right answer as it normally does, mostly for formatting days and times given to you. You'll have to remember how to format them, unfortunately. Well, unfortunately, it's not exactly intuitive, and most real-life Python programmers I know will just Google the answer for this one, but you will have to remember it for the exam. They're not going to give you Google, sadly. So, just an example here: X datetime, and then you've got, say, a date and time. As you can see, this bit is quite intuitive: year, month, day, hour, minute, second. So as you can see, this bit is the non-intuitive bit. You've got %b, %d, %y, and then %h, %m, %s, and you have to remember whether they're uppercase or lowercase as well. %y will give you a year like this if it's uppercase, and if it's lowercase it'll give you just the last 2 digits. So just remember that as well. It's as I say, this is one of the pains of an exam, is that you have to remember things that normally you wouldn't need space for in your mind. Okay, the actual conversion table is somewhere on the internet. Hang on, we have the Python pages right here. And as you can see here, we've got %a, weekday as local, so Sunday, Monday. So it's got all these examples here as well. You've got A, W, which is a weekday, D, which is a day of the month with a padded with a padded 0. As you can see, capital B here, month full name. So I would certainly print this out, try and remember it, especially the ones that are a little bit more complicated. Y for year you could probably remember, but for example, B, where is it? For the month is a little bit more difficult to remember, I think. Just, yeah. So I can't help you too much on that. I'm sorry, you guys are going to have to use your memory there. Okay, thank you very much for watching, guys, and I will see you in lesson 3, where we will go through some actual exam questions. Okay, bye-bye. Hi everyone, and welcome to chapter 3, lesson 3. In this lesson we're going to cover some of the stuff we haven't covered in the previous lessons, and also go through some exam-like questions that might try and trip you up. So, differences is the first thing I want to go through. As mentioned in the last lesson, the exam will want you to differentiate between formats. It'll ask you to print the differences between .2f and the .2f. Hint, some countries use this to represent a price, and some use the dot. So that's the difference here. If it's asking you to print dot, then you need a dot there. If it's asking you to print it like this, you need this here as well. And remember, this is sort of your invisible location here. You sometimes don't need it, you sometimes do, depending on what you're doing. It may even be sneaky and give you an answer with a hash before it, and I have actually seen this. It's terrible. So just be very careful of that. Always make sure you read it, because this is obviously a comment and will never be executed. Yeah. So as I said, this would never actually print anything because it's commented out. A float will automatically round the number. So if you specify 2f and then give it 60.929, it'll actually round it to 60.93. This is good, for example, if you're just rounding up and down with pennies and you want, the exact amount there, that's fine. But it's just something to be mindful of in the exam. A bit about scientific notation as well. E is for exponential notation. It'll always display it as powers of 10. So 900 is 9e plus 02, basically. Basically, it'll always show something between 1 and 10 here. It'll never go above there. For everything else, it'll just use the plus and minus 1, 2, 3, you know, and keep going up. And that's how we get very, very, very big numbers in Python. This can also be referred to as scientific notation in the exam. It's actually exponential in the Python docs, but the exam likes to call it scientific. So just be aware of that little difference. The exam may also ask you to right align a number. Now, I really can't figure out what this it was actually asking here. So 22F would be 20 decimals. A simple 1 in there would actually just be like this, but the zeros will not appear, so it'll just put the 1 all the way to the right. That's pretty much what a right align is, I believe. Oh, sorry, that all came through at once, that's fine. So sys.argv, and we'll go through the right align stuff again in a second. Sys.argv is basically arguments given to the code to run. You can start a program with Python and then app.py, and then this will be your argument, run this. So you can actually access that from within the program as sys.argv1, and that would be run this. The reason it's 1 is because 0 is the initial part, the Python app.py or the program, and 1 is your first argument. So a little bit about join. Join may also come up here. It's called in exactly the same way as format. You can make a list or a tuple or a set. So for example, we've got my list howdy cat dog here, and a join will basically turn this into a string again. So if we print just a space here and then join, it'll basically print the list as a string. And I have some examples here to show you guys as well. Not of that one, but yeah. Give me one moment there, guys. Save as string example. Right. Okay, so I'm going to show you guys an example of that. So my string equals, hang on, my list. Call it my list. So we'll put cat, because I like cats. We'll put kitten. We'll put dog and lion, for example, there. So there we've got a nice list. So if we print my list, we can see that's going to print right there. There's a nice little list. There we go. Cat, kitten, dog, lion. Now, as you can see, it's a list. We can go through it. But what we can also do is do my list. So I believe then we can just print mylist.join and have that in there. Hang on. Yeah, it might not be .join. Ah, yeah. Sorry, I've got that the wrong way. Yeah, that's something else as well. The .join is actually the other way. You print the thing and then you just join the list inside. So my list here. There we go. So now if I run that, as you can see, cat, kitten, dog, lion, it looks a little bit different to how it did earlier with the brackets. And then if we get the type of this, it should actually be a string. So as you can see, if we do a type here and then we run that, that is a string. As you can see there, that is a string. So as you can see, this list we have turned back into a string again, and we can turn it into a list or a string as needed, which is good. So a bit about even spacing as well. A format command can be used for even spacing. E.g. 06 would get the argument 0 and give it 6 spaces, even if it's shorter. Jack would be given the same space as Jackie in this case, and that's what we have over here in string format. And we also have the right align option that we had earlier as well. So if we start debugging this, As you can see, the right align actually puts the 1 all the way over here. These are all zeros, but obviously it's not going to show them because you don't need to show a lot of zeros in front. So this is a right aligned 1 with two decimal points after it. That's basically that. And then these 2 prints here, as you can see, these stars are in exactly the same place, and that's because we've put the 6 here after it. So this 6 will ensure that it always has 6 spaces. So Jack and Jackie have the same amount of space there before it gets to the stars, and then we can put whatever in after. And it just makes it look quite pretty, but the exam may ask you about that as well. Okay guys, thanks for watching, and that about wraps up Module 3. I will see you guys in Module 4, where we'll go through some error handling. Bye bye, thank you. Hi everyone, and welcome to Chapter 4, Lesson 1. In this lesson, we're finally going to be going through Python functions. I'd have thought it would have come a bit earlier in this certification, but it actually only introduces itself in Module 4. So, functions. Functions are a very important part of Python. They allow us to rerun code as needed. So if any of you ever touched assembly language at school, or played around with it a little bit, it's basically the go-to. So you go to a certain bit of code and rerun it. We can start a function using the keyword def or define, and inside the function we can run any code with the arguments given. So you can think of it as like a mini program, and this is where we kind of get away from the assembly language stuff. So basically you have local variables, and they are self-contained, and that includes anything done in the process, so it's all thrown away at the end afterwards. You can think of it as input, process, and then output. So anything in the process after it's completed is just thrown away. And we can then return an answer using the return keyword. You give the input from the main program, but it's actually going to be copies that are transferred into the function. So your function is always working on copies of what you've given it. So it will never change the original inputs in the main program. It can only change what's inside the function itself. The output can either be printed or caught in a variable and used later on. So a little bit about default values as well. We can also give a function a default input. That is, if nothing's given, then it will just use the default and it'll be happy. So we can then call a function without any arguments at all, and it'll just use the default ones that are already there. Without the default, you must specify the amount of parameters that are needed. So for example, if a function needs 3 parameters, you have to give it those 3. Otherwise, it'll crash and you'll have an error. For example, we've got a function here called myFunction, and it says A is 6, B is 8, and sorry, there should be a DEF and a colon here, of course, but this is just a pseudocode example. And we can call it just as myFunction, and then A will be 6 and B will be 8, because we already specify the defaults here. We can also override them. So calling myFunction 1010 would make A10 and B10, and this is when we're actually calling the function later on, and we can call it as many times as we need. The other thing is the old call will not affect anything with the new call. It all resets. Everything inside the function is reset. So this is why, for example, if we set x is 0 and then up x to say 5 incrementally, when we call the function later on, x will still be 0 and it will do the same thing. So let me show you some examples of the functions before we go on to unpacking. So as you can see here, we have 2 functions. We have one for add 5, which basically gets the first number and adds 5 to it, and then it returns a number out. And then we've got add given as well, which takes 2 arguments. As you can see, we have default here, so default 8, default 10, and again it sets the last and it returns first and second added together. So if we run this real quick down here, hang on, there we go. So we've got 55, 60 and 100. So the reason for this, we've added 5 to 50 here. So first number in this case is going to be 50. It'll add 5 to first number and then return last, which is what we've defined it as. We could also do it simply as just return it straight up. We do not have to return a variable. We can just return something like this and that would work too. So then we look at add given, which basically allows us to add first and second. So as you can see here, we've given the first argument as 50. The second is going to be 10 by default. So this is why this is 60, because we've just given it and it's just come back. And then on the second one, we override both. So first and second are not 8, not 10, but instead it's 50 and 50, so it will return 100. And then as a final one, we can also just add given without any parameters, and that should be 18, I hope. Yep, there you go, 18 has appeared down there, which is good. And then, 1 second, so we can also down here do x is add given. And then print out x later on. So this is just to show you guys that you can assign a variable to the output of a function. So as you can see, return last is there, but then it actually goes into x, and then we print x out there at 18. But it's also important to remember that, as I say, this first number, these are all local variables. So if we try and print these outside the function, as you can see, it's already underlined it, it'll throw us an error because it's not defined. It's defined in the function, but once we return, the function's gone completely. So the function is self-contained, it's its own thing, and it can't get anything from outside. Sorry, you can't get anything from the function. It can still get things from outside. Unpacking arrays. We can use a start when we call a function for the parameter. This will unpack an array for us so we can pass it correctly into the arguments. It's just a quicker way than doing it ourselves. And I know it looks a little complicated here, so I'm just going to show you guys one small example of that again. And as you can see, well, this will all click into place immediately at this point. So my list here, we've got 1 and 6 in there, and then we do an add given and we do star my list. So instead of sending star my list, it'll just expand these, and it's just like giving 1 and 6 like that. Those are both the same. So if we run it with 1 and 6, we should get 7. Yeah. If we run it with star my list, we also get 7. So, as I say, just another example here. If we have an array m equals 1, 5 and 8, and a function that takes 3 arguments, it'll just pass 1, 5 and 8 straight to the function. Passing none to a function, though, is kind of like passing nothing, but not really. In Python, none... So, as I say, just another example here. If we have an array m equals 1, 5 and 8, and a function that takes 3 arguments, it'll just pass 1, 5 and 8 straight to the function. Passing none to a function, though, is kind of like passing nothing, but not really. So, a little bit about none. In Python, none is a null type. It's called a non-type, basically. But it can be passed as an argument to a function, which is where it comes important here. The function won't be able to do anything with it. With a non-type, you cannot assign anything to it. You can't sort of give it anything. It'll just, except to reassign it. As I said, so if you want to reassign the variable, you can do that. And if you want to check if none has been sent, you can do that as well by just doing... so if x is none, like that, and that will just say if it's none, print hello, for example there. Show you guys this. So if I say x is none, there you go. And as you can see, hello print, so x is none. That's all that is. It's sort of just nothing, but not really nothing. We can use it, for example, if we want to check if something really is nothing. We could use -1, like we do in some other languages. You know, we could say x is -1, and then if x is -1, print nothing was sent. You know, that could work as well. But instead, we do it like with none, just because it's not as ambiguous. And there are plenty of documents around the internet and stuff that'll teach you a little more about this as well. It won't outright fail, so if we don't send the right amount of parameters at all, and we don't have any default values, basically our program will crash. Okay, thank you guys for watching that, and I will see you for lesson 2 very soon, where we'll be going through some Python documentation and how to generate the docs. Bye bye. Hi everyone, and welcome to chapter 4, lesson 2. In this lesson we're going to touch upon modules and what they are, and we're also going to go through PyDoc, which isn't the documentation tool that I would have chosen, but it's the closest to Python, and I can see why the exam has chosen it. So, a little bit about modules first. Modules are the things that we can import into Python to make our lives easier. Basically, if we want to talk to another service like Slack or AWS, we can do it through a module and then call functions from that module that will basically layer away all the more difficult things that we have to do. So for example, if we want to talk to Slack, we can provide the Slack module with an API key, and then it will go ahead and sort all that out for us. And then we can just call the send message function, and it'll just send a message for us. So it basically layers away any of the HTTP stuff, the getting, the requesting. It sort of gets rid of all of that for us. They can be made by community members or the Python team. They're mostly on something called the Python Central Repository, or pip. And there's lots of modules out there, of course. The one we're going to focus on this lesson is PyDoc, and PyDoc is a module itself, but can be used on other modules, if that makes sense. We can import a module just by doing import. We can import a module by doing import module at the top of our code. So a little bit more about PyDoc. PyDoc will allow us to automatically document any module. So we can create the module and then use PyDoc, and it'll all be nicely documented at the end. A module is generally a lot more complex than the ones we'll be using here. I've basically got a small example with 2 functions that add some numbers, a bit like we used in the last lesson, and that will basically be the example for you guys for PyDoc. I'll show you some of the built-in ones too, to kind of see what they are and see how they work. And PyDoc is directory sensitive, so make sure you're in the correct directory when you run it. So it does take a module as an argument. So if you run it with the module argument, it'll look to see if it's in that directory. If it's not there, it'll look at the Python built-in and see if it's there as well. So for example, if you have a module called sys in your local directory, it'll use that. If there isn't one called sys, it'll then use the built-in Python sys module. It will look at anything, as I say, it'll look at anything local and then at the Python built-in stuff. So a little bit about the headings and how we give them to PyDoc. It has a few distinct headings that we have to set. Name, occasionally with the description as well. Functions is basically your functions and your documentation. If you don't provide documentation, the functions will just give you a list of functions. Data, which is any variable assigned in the module and what it is to start with. Version, we can assign it by just setting __ version __, and we set that to say 1.0, you know, somewhere near the top of the file, and then when we run pydoc, it'll come out with 1.0. And the same thing with author. Anything else such as copyright will go in the data area. Just remember that, because the exam may ask it. You know, some different documentation modules and GitHub, for example, they will use copyright, they will use license and stuff like that, and they'll go through and look for them and then assign them automatically using that. So as I say, this is by far not the only way to document. This is quite a primitive way to document, but it's a good, you know, get your feet wet kind of thing. So a bit about assigning the documentation. If we want to assign documentation to a module or function, we can do it with 3 quotes. So we can do it with the single quotes or the double quotes. Either one is fine. As long as it's in the correct place, pydoc will pick it up. So it's called a doc string and is assigned automatically to thing.doc. So as I say, you can document a function, you can document a module, you can document a class. I know we've not been through classes yet, but you guys should maybe understand a little bit about them already. There's also annotations, but that's mostly handled by third-party libraries, and I've not seen this come up in the exam. So let me show you guys some examples here. So I'm just going to clear this away. So here we have the function array that we had earlier, and as you can see, I've basically added a little bit of documents here. They're called doc strings. You know, we've added the author, the version, and the copyright explicitly, and then we've got a doc string here as well that's commented out. And as you can see, doc string here, doc string here. So we can do it with single, or we can do it with 3. Most people do it with 3 because then it can go like multiple lines like that, and you can just add and select, and it's basically like a notepad file in the middle of your Python. So most people do it like that. So if we now run the pydoc, we basically need to run it by using Python and then -m pydoc, and then finally we need the module name. So for this one, it'll be funcarray because we're funcarray py. We don't want the py on the end, we just want funcarray. So as you can see, we've got help on module funcarray here. So, sorry about that. So here we go. Let me just, alright, I'm going to get rid of that for now. There we go. So we've got help on the module, we've got the name, and then our description there. So name, description. We've got functions, and as we saw earlier, we have just the docs in there. It's the first string after defining the function, of course. And then we have the data. As you can see, the copyright's gone in here because pydoc doesn't really mind. You know, we could put anything there. It could be copyright, it could be license. It all just goes into data. And as you can see, x equals 40 down there and in data as well. Version is something that pydoc cares about. So as you can see, we'll set our version up here, and you know, we'll bump it up 1 for next time. And then author as well, and finally file. File we didn't actually set, but it knows where the file is, and it'll set it and display it automatically. So if I now switch this doc on here, and then run this again, as you can see, now it's got yo up there instead of our example pydoc function, and that's because this here is just doing exactly the same as this on doc equals. It's basically guessing, like it does with the variable types. It's just taking a guess as to where these things should be. You know, it thinks, oh, it's the first one after, first string after the function. It must be our documentation. Okay, thank you guys for watching that, and I will see you next lesson. Next lesson, we'll be going through some of the gotchas in this module and finishing up. Thank you very much. Bye-bye. Hi everyone, and welcome to Chapter 4, Lesson 3. This will be the last lesson of Chapter 4, and then there'll be an exam afterwards. So, there is another way to access PyDoc. And basically, we can access it by importing a module first, and then calling help on the module. So, let me show you guys an example of this. As you can see here, we're in the code folder, and this is funcarray up here. So if we do Python, and then import funcarray, and this will import our little code here. So as you can see, x equals 40, that's all that's going to happen there. So then if we do help on the module we've just imported, it'll give us the PyDoc in a very helpful way, just in the terminal there. So we would import funcarray and then do help as I've just shown you. This would show us the same as Python -m, PyDoc and funcarray. So a bit more about the doc string as well. I'm sure you guys remember it from the last lesson. It can either be given with underscore underscore doc underscore underscore equals, and then obviously whatever your documentation is. I've just put example here, or a simple string at the start of the module, of course. However, this does mean that our indentations must match. So if we're doing it in a function, it needs to be one indent within that function. And let me show you guys a brief... Oh, hang on, that's the one. Let me show you guys a brief example here. So as you can see, we have docs here, which is our doc string. So if we then do that, and just do define and then docs there, and then run it, as you can see, we actually get an indentation error, because this is actually run by Python. In some languages, you know, you just have it, and then the actual compiler wouldn't listen to it. In Python, it does listen to it, and this is how PyDoc gets its stuff as well. So just be mindful of that. You may get sort of tricked in the exam with that one. Python, as I say, does not ignore this code. So a little bit about the help generation as well. It may ask a bit on how we can view the help. We can view it in the console, as I showed in the last lesson and just now. However, we can also view it in the browser. So then we can also do this as well. So let me show you guys real quick. PyDoc -p, we'll say 8080, and then we'll do funcarray. And there we go, the server's ready at 8080. So if we now say browser, there we go, it'll give us the list of modules right here. And we've got the built-in, and then we've got the code and all this as well. So, and there's funcarray right there. Because we we made it go a bit wrong, if you remember, a little while ago. So if I just fix that now, there we go, and then quit that and do that again, and then we do this again. There we go. So now, as you can see, it gives us the description from last time, the functions, the data, the author. You know, it gives us it all in nice colours and everything as well. So, and then it also gives us everything else that's ever in Python here. Yeah, asteroid. I'm not even sure what half of these are, to be honest. But this is our little area for pip, or the central repository, to put things. And as you can see, it gives us a documentation for, say, Slack right here. Yeah, it'll tell us what everything contains. Client. You know, it'll give us huge amounts of documentation from these actually rather large methods. So if I go into, say, Boto, which is Amazon, and then if we go DynamoDB, for example, you know, it'll tell us conditions, classes in here, it'll tell us the functions in them, and it just tells us all that, so we can take a browse through and see, you know, how to use these functions. But we can also just, you know, Google it these days. A lot of us just Google it. But it's very useful if you're offline, you know, or the documentation just isn't there in some cases. If someone creates a module very quickly and just puts it online and forgets about it for years, and you need that specific bit of code, you know, this is quite helpful for you to then go through and work out exactly what's what. So as I say, py.-p would start it, and then you can browse to it in your browser. Py.doc can also write HTML into a HTML file by just using py.-w. It'll just put it right where you are. So if you're in ctemp, it'll write ctemp funcarray.html, for example. It cannot write any other files by default, and the exam will try and test you on this. So it can't write PDF, it can't write JSON. You know, you can get it in the browser and then save it as PDF, but apparently that's not enough for the exam. So just remember, it can't do PDF or JSON or anything. So some final tips for Module 4 as well. The exam may use stuff from the last few modules, so do make sure you review them. It'll use the greater than, the less than, the ifs and the elses. So do make sure you review them before you do this practice exam. As I say, it loves to use the ifs and elses, this one. That's because we would normally do a lot of this in a function, to be honest. So in Module 2, you know, we noticed we didn't have functions, we just did it straight up. And then in Module 4, it'll try and redo this within functions. And when we import a module, the code is actually run. So if we go and look at our module here, when we're creating a module, we want everything to be in a function so that it's not actually run. And then the only thing that's run here is setting x to 40. Nothing else. Until we need it later on, of course. If we want to ensure the code wasn't run, we'd just use if __name equals main, and then there should be a colon on there that's always dropped in PowerPoint for some reason. So then we can just simply import it and then call whatever we need to do. So funcarray.add3numbers, yep. And we give it 4, 5 and 6 like that. It'll give us 15 back. This ensures the code is only run if we are running the Python file directly, and that's this bit here with the commas and the colon missing. Okay, thank you very much guys for watching, and I hope you do well in the test, and I will see you guys in Module 5. Bye bye. Hi everyone, and welcome to Chapter 5. I hope the practice test for Chapter 4 was okay for you guys. I think that one was a little bit easier than the others, and a few things should have dropped into place regarding modules and functions. So all good there, and if you didn't manage to pass, that's alright. You know, we're only preparing for the real thing. So in this lesson we're going to go through errors and troubleshooting, and I think it's quite an important part, but it's only 5 to 10% of the exam. But the only thing is, this is very open-ended, so you need to try and figure out exactly what's wrong. And this is something I can kind of coach you guys on and let you know what came up in past questions, but it's something you're really going to have your eye on to figure it out. So there are 3 distinct types of errors in most programming languages. The first is a syntax error, and this will basically be caught the moment you try to run the program, and it'll probably come up with a nice helpful traceback and say, hey, I think you've gone wrong there. The second is a runtime error. So the difference between this and the last one, so the first one, basically when the program converts it into code that the computer can understand, that's when it will find it. But the second is a runtime error. So you've already converted it into code, the computer's running it, and then you'll crash it halfway through somewhere. And that's what a runtime error is, and it will only reveal itself while it's running. The third one is a logic error, and is actually nothing to do with Python, but it's instead the programmer. And we'll go through some of these very soon. So, a syntax error. A syntax error is caught, as I said, when you pass the program. So the moment you click the run button, it'll do a pre-parse, make sure everything's okay, and then send it to the CPU. Basically, I mean, it's it's a bit longer than that, but I'm going to say basically. So basically, it'll catch it there. You've seen us trigger errors with indentation in the last module, and that was a syntax error. It catches it before it even starts running. It's caught immediately, and the interpreter will then tell you where the error is and how to fix it, hopefully. Occasionally, you know, it might be slightly wrong. It might say it's on line 5 when it's on line 4. It's just kind of a best guess for the program where it found the error. For more complex errors, you know, it's a little more difficult. For something like an indentation error, it can say, yeah, that's probably the problem right there. Common errors, leaving out keywords such as in and as out of the program, which would cause a crash, or missing colons. Python will attempt to show you where the error is in a traceback. So I'm going to show you guys a quick example here. We've got our errors py here. So I'm just going to get rid of that for now, because that will crash us for a reason that I will tell you in a bit. So if I get rid of this colon here, for example, and then run, as you can see, we have a syntax error, invalid syntax. So that was caught immediately. The program never even tried to run. As you can see, it didn't even print hi there. It just crashed out. So a runtime error. Once the program has been parsed and starts running, there can still be traps in the code. Consider integer x. If x is calculated earlier in the program to a string, it'll actually fail to convert to an integer, but it won't know until it gets there. So it won't know at the start, like with a syntax error, it'll know later on. And then it will obviously crash because it's not very happy. You can think about it in English too. If I tell you to flap your arms and fly to China, the syntax is correct and you understood the instruction. But obviously it can't be done and it's impossible. So that's basically what a runtime error is. We're telling the program to do something, it can't be done, so it goes, no, sorry, can't do it, and crashes. So a logic error, also known as a layer 8 error or a user error. You know, there are many different ways to say this, but logic error is the official term, I believe. It's a logical failure in the program. For example, if you use the wrong variable name, you know, you've used A instead of B, or you've added the wrong thing, or you've used the wrong order of operations. So instead of 5 times 5 plus 5, you do 5 times 5 plus 5. So this will be 30 versus 50. So, you know, you might want 30 and you might get 50 and you might not even know it until you're way down in the program and saying, why is that wrong? And then you have to try and trace it all the way back up without any help from Python at that point, because Python is fine. It's running, it's no problem. But there's a problem in the code that you have created. So following on from our last example, I'd tell you to buy a plane ticket and get on a plane to China. But I actually wanted you in Japan, so that's my fault. You did it, you ran it okay, but you ended up in the wrong place. Pandemic, obviously not factored in there. Yeah. These errors can be very hard to track down because the program won't crash. So, descriptive errors. Runtime errors are the most descriptive. Value error, as described before, is when the interpreter cannot transform a thing into another thing. A zero division error is basically when we try to divide by 0 and it doesn't work. So, for example, you might have 0 somewhere in your code that you wanted to change at some point and you didn't for some reason. Maybe you forgot, you know, maybe the data that's coming in is wrong or isn't there, and you just get 0 out and then you'll get a zero division error later on. Type error is given when you pass too many arguments or the wrong types to a function. If you try to get something out of bounds, for example, a list only has 5 items, but you're trying to get, you know, the 10th item, it'll just give you an index error. And a dictionary doing the same will give you a key error. Okay, so I'm going to show you guys some quick examples of these. So we're going back to our errors py here. So as you can see, we have some things commented out here. Now, let me just sort our syntax error out from earlier. There we go. So if we run this now, there we go, it runs, it prints high and it prints 14, which is great. So first thing we're going to do is we're going to try and convert x to an integer. And if you watch, and this is how you can tell whether it's a syntax error or a runtime error. So it actually prints high here. It's gone through the program, it's gone through this, and then it's crashed here on line 12. And it even gives me a pointer and says, hey, you've crashed. That was that's VS Code rather than anything else though. So then we can cancel that, I guess. And as you can see, it even gives value error, invalid literal for int, base 10, hello. So very descriptive and very helpful errors here. And then we're going to try and do this thing. And you can see this thing up here doesn't take any parameters at all. And you can see it's already underlined it. So we're going to start debugging that. And as you can see, this thing takes 0 positional arguments, but 2 were given. And this is a type error. And as you can see, it's still printed high there. So it's a runtime error, it's got through, and it's crashed. Oh, there we go. And as you can see, again, the error is a type error. And finally, I'm going to show you guys this one, which is where we get 10, and there's only 5 items. As you can see, it's got through part way, and then it's gone index error, list index out of range. So it could give the exam, try not to focus on any one particular error, because unfortunately it can throw any error it likes at you and try and make you track it down. Sometimes this exam does like to give you a bit of code and then ask you on which line is the error. So then you've got to go through the code, figure out, is it line 5, is it line 7, is it line 12, and try to figure it out that way, and try to figure out where the integers and variables are going through and all that, and try and figure out, what the problem is. Is it a runtime error? Is it a syntax error? Will it even start? Okay, so a few more examples here. Non-default arguments, i.e. arguments without defaults, must actually come first. Then the arguments with defaults go after it. And it's a very helpful error, is this one. I will show you guys right now. So if we say A is 8, and then B, and then U is 8 as well, and then let me just comment that wrong line out. There we go. As you can see, very helpful error, and it's a syntax error, so it's one that happens before the program's even started. And it says non-default argument follows default argument. And the reason for that is just the ambiguity. It makes sense because we cannot assign this. It is ambiguous. If we send 2 arguments, Python isn't sure if we're defining A and B or B and O here. So A and B and O isn't sure. We might be defining B and O and leaving A as 6, or we might be defining A and B and leaving O. But Python's like, well, I'm not sure what you're doing. Input will always produce a string, even if we input an integer, by the way. Just so you know, this did come up. So just remember that. So if we enter a number and then we input 14, it would come out as a string. We'd have to convert it to an integer if we wanted to actually add things to it or do anything like that. And again, I think we went through this in Module 1, but var is not the same as var or var, different capitalizations. The advice would be just avoid having same name, different capitalizations. Not generally a good idea. Okay, thank you for watching that, guys, and I will see you next lesson where we will go through how to catch some of these errors and step past them in the runtime. So this is the runtime errors only we're going to be focusing on next. Okay, bye-bye, thank you. Hi everyone, and welcome to Chapter 5, Lesson 2. This will be the final lesson of Chapter 5, as it's only 5 to 10% of the exam, and it's very open-ended. So in this one we're going to go through try, except, else, and finally. I'm sure you guys remember else from the if and else. It's quite similar here as well, but used a little bit differently. And I'll show you guys how to do that very soon. So try and accept. Try and accept is a method to catch runtime errors as they happen. It doesn't catch syntax errors and nothing catches logic errors because Python basically blames you for those. So it just catches runtime, but it is useful. It allows your program to basically handle the errors quite gracefully. So rather than crashing in the middle of a program, or if you're running a website and with Python as the backend and the Python backend decides to crash, then you don't want to be getting up at 2 in the morning to bring it back online. So this allows your program to basically handle the error, store it somewhere and go onwards with other things and not crash. Simply wrap the code you want to attempt in a try block. Then if it goes wrong, you can skip that part and display a helpful error to the user. It's simply 2 blocks of code for the try and accept, and the accept part will not be run if the code in the try block does not crash. So a little bit more about the accept. And this is an example of how it would run. So we've got try, and then for example we convert in x to an integer, but if x is actually a string that says hello, obviously we'll get a value error here, which is this accept, and it'll just print exception and then continue with the program. You can do the accept with any of the runtime errors mentioned in the previous lesson, for example 0 division error, index error, etc. But it's generally good practice to be as specific as possible and handle different errors in different ways. For example, you might handle the 0 division error in a slightly different way to the way you'd handle a value error. For example, if you're pulling in third-party data and you've got a value error, then you might want to pull in like an old version of this data to continue with the program in the accept block. However, you can just do accept if you want to handle all errors, and I'll show you this in a moment. You can have as many accept blocks as you like for this purpose. So a little bit about else and finally before we go on to some code. Our good friend else can also be used after a try and accept block. The else statement here basically says if there was no error, then do this. So if there was an error, the else statement is not run. If there wasn't an error, then the else statement is run. It basically allows your try block to be as small as possible and go around a little bit of code that you think may go wrong. And it's always good to keep your try blocks small because the more stuff you have in there, you might have 2 different things that could cause errors and then you're not sure which one or how to handle it. If there was an error, it'll do the exception block instead and then skip the else block. And the finally block will run whether there was an error or not. So a little bit about throwing exceptions as well. We can throw exceptions ourselves. We can use the raise keyword for this. So for example, we raise a value error with an unsupported type here. But if this isn't in a try and accept block where it actually raises it, it will again crash the program. This would raise a custom value error and crash if it wasn't handled with a try and accept. So I'm going to show you guys some examples. As you can see here, we have our code from earlier. We have this thing which we're not actually using, so we'll just leave them there. We've got print hi here just to show you guys that works. Let's just clear that out of the way. And then we've got x equals hello, and we'll try a string x. If it's a value error, we'll print the exception. If it's not a value error, any other exception, we'll just print a generic error. If it was fine, we'll print all was fine, and then finally we'll print this will run no matter what. And after handling the errors, it'll print this add together down here as well, which we are using from there. I didn't realise that. Okay, so let's start debugging that. As you can see, we get the hi, we get all was fine because we're converting a string to a string, so it's going to be fine with that. and then we get the finally this will run no matter what. We don't get any of the exceptions, it doesn't even run these blocks at all. And then finally we get the 14 out of the bottom because the program continues after handling what it's handled above. So let's convert a string to an integer, which we know we can't do. So we know this is going to bring us an error. So let's start debugging. And here we go. So it actually prints the high again, but then prints the exception. And as you can see, we've got except value error as E here. So basically, as E means that the value error becomes a string. So then we'll convert it to a string and just print the exception out there, which is here invalid literal for int with base 10 hello. So the next thing that I wanted to show you guys is the generic error. So for example, we can't get an int of x, but what we can do is do a string and then get the 9th character. Obviously there's not 9 characters in this x here, so we're going to have an error. It's going to be an index error. So it's not going to be caught by this value error here, but it will be caught by this except block here because it doesn't specify the specific error type. As you can see, hi, and then generic error here, print, and then this will run no matter what in the finally block there, and then we get 14 out here. So I also want to show you guys a raise. As you can see, we can raise a value error here. We'll do this outside the try and excepts, and we'll just go ahead and start debugging that. As you can see, because it's outside the try and excepts, and the exception has occurred, unsupported type, it just gives us exactly what we want there. So this will crash the program, unless you're putting it in a try and except. It didn't get to this print down here. Okay, a little bit on exam tips as well for you guys. This module is very open-ended. As I say, it's only 5 or 10% of the exam, but it is quite open-ended. So you'll have to memorize some of the stuff behind errors and how they happen. And they can put a logic error somewhere and tell you to find it. They can also put runtime and syntax errors in as well. Generally, the last for the line, the error is on. And a tiny bit about try and except as well. So I'm going to make the practice exam as close to the real thing as possible. There's some stuff that I haven't been through here that will be in the exam because I want to make it as open-ended as it will be for you guys, because there's no way I can go through every error and how it would appear. So there's got to be a bit of thinking on your part, and I hope the practice exam basically kind of ignites that part of your brain. Okay, thank you guys for watching that, and I will see you in Module 6. Bye-bye. Hi everyone, and welcome to Chapter 6, Lesson 1. In this lesson, we're going to be going through modules and a specific one called datetime. Now, in the past few modules, we've obviously covered just one thing. This module is very, very broad, and it basically covers a lot of different modules that you can import into Python to extend it. Now, I would personally say this is the most important module. In the actual exam, it's only 2 to 5% for some reason. So the other modules for you guys are more important. If you're actually doing practical Python and want to go ahead and code afterwards, this is the most important module for you. Okay, so let's continue on to modules first. As I said, we've already covered some modules and some of the errors as well in other chapters of this course. But this section is dedicated to them. And as I say, it's only 2 to 5% of the whole course, so there'll probably be 5 or so questions on modules. And there'll be very common modules such as OS and datetime, and we'll go through each of these and how they may work in a minute, as I say. But first I'm going to go through some associated errors with you guys that may come up in this one but wouldn't have come up in Module 5. As you can see, there's a little bit of an overlap here with pretty much every module. So the associated errors. In the last module, we went through some common errors and troubleshooting. One that we didn't yet cover is the attribute error. And it's raised when we try to call a function that doesn't exist in a module. So for example, if we call datetime.directory, obviously the module doesn't have this function, so it will raise something called an attribute error. It doesn't actually make much sense. It should be a more what's the word, common name, but just remember that it raises an attribute error and you will be fine. Another one is the unbound local error, which happens when we call a variable within a function but we haven't actually defined it or brought it in from elsewhere. Alright, so we're going to go through some of the datetime functions as well. We went through some of the datetime formats with %b and %y and you know all the rest of these formats in module 3, which you will have to remember for the exam. There's also a whole module called datetime itself as well, and we can use this to manipulate and get times from Python. It needs to be imported in a special way to use it directly, and more modules in Python have to be imported this way, so the exam may try and test you on this as well. So it needs from datetime import datetime. So this is the module, and then this is what we're importing from the module. We can also have from datetime import time delta, which is another piece of the datetime module. And as a module grows, especially you know a big public one, they try and modulate it down even further. So you're importing different things from the main module but never importing the main module, if that makes sense. And so before we could just import datetime, and you can still do this now, but you have to then do datetime now to get the time now, for example. And I'll show you that in the practical very soon. And as I say, it allows you to use datetime.now. For example, if we want the time right now. If you didn't do the from, you'd need to use datetime now. But then you could also have time delta there as well. So you just do datetime.time delta. Again, it's up to you which way you import things, but the exam will likely test you from both. So a little bit more about datetime as well. They are actually a type of their own. So it's not an integer, it's not a string. It can actually bring its own type in, and you can then manipulate that type directly. It can be added, subtracted, and converted with another datetime as needed. We can use methods under the datetime to get, under the datetime attribute to get the data in different formats. For example, if we need a timestamp, which is seconds since 1970, we just do datetime.now.timestamp, and that will then give us an integer of the seconds since 1970. So as you can see, within the datetime there are also functions and methods that we can use to then get things out in standard Python. This will get the datetime object of now and then print it as a timestamp with an integer. So then you can do whatever you like with the integer. You know, you can add 1 to it if you like. You can do whatever you like to it after that. So a little bit about comparing dates and times as well. We can compare dates by simply adding or subtracting date times, and from that we actually get another type called a time delta. Consider getting the total seconds between 2021 and 2022. So I'm not sure how many seconds that is, but we will find out very soon. These are two datetime objects, and we can subtract one from the other. So then this would just subtract one from the other if we ran this directly, and it would give us a time delta. We can use dir to see the methods and variables from the time delta. Total_seconds is the one we want. So now I'm going to go on to a little bit of a practical with you guys here. And as you can see, we've done it a little bit differently to the way we did it in there. We've said from datetime import datetime, from datetime import time delta, and I'll show you the other way to do this in a second. So then we've got datetime.now, and we can print that as well, of course, because otherwise it's not going to print. And then we've got example date time now plus time delta days minus 100. So as you can see, although we're adding, we're actually subtracting, because we're subtracting the time delta. So that will then give you a time delta with days minus 100, and then we can print the example out here. At the moment we just print a directory of it, as I said earlier. So let's run this. So as you can see, we have datetime.now, which is printed right here. And this is just a... sorry. And this is just a simple datetime object. And then we've got a directory of what's in example. And as you can see, if I hover over it, it tells me it's a datetime there. So then we've got exactly what's here. So the time delta is just for plussing and minusing. The date time is what actually displays the time, is basically the way you need to think about it. And there's a lot of modules that will try and do this to you and add new types, and you've got to try and convert them between different types and get them back into standard Python. This happens a lot, so just be aware. So now if I just print the example out here, which again is a datetime. As you can see, we've got datetime.now, and then we've got datetime minus 100 days. It's also worth remembering that days is the largest value that we can plus and minus. So if you want to minus a year, you just do minus 365 there. Actually, it's stored internally as seconds and milliseconds as well. So days and minutes and whatever are actually done by the program out here. And it's stored internally as seconds and milliseconds and then converted as it goes in. Just some internal Python for you guys there. So I believe that should be it. Let me just show you guys a plus 100 days there, or we'll add 365. I'll get you the total seconds as well, probably. There we go. So we've actually got 2021 there. Yes, next year. Hopefully the pandemic is gone. So something else I want to show you guys is the way to add two dates together. Maybe you don't have date time now. Maybe you just need to add, say, 2022. Sorry, I'm going to go with 2020. 8-1, and then in here I'm going to go with 2028. We'll go with 7/25 there. There we go. So those are two date times, and we can subtract them. And then if we go total seconds here, that should give us the total seconds between those two date times. Now, example is actually a time delta here. So it's the example that's the time delta, and you can see it there. It knows it's time delta because we're adding two date times. Okay, thank you guys for watching that, and in the next module we'll be going through some more of the common, in the next video we'll be going through some more of the common modules in Python. Thank you very much. Bye bye. Hi everyone, and welcome to chapter 6, lesson 2. In this lesson we're going to be going through some of the other modules in Python. There are 4 main ones that I saw on the exam, so we'll be going through those, but don't discount the fact that they may throw some other standard modules at you as well. Generally, it's quite easy to decipher what they do, especially if you guys have done revision and maybe you know about the module already. But we're just going to go through four simple example ones, and we'll go from there. So the first one I want to go through with you guys is math. This one is probably definitely going to come up. Sometimes we want to do something a little bit complex with numbers, for example factorials. You know, we just want to do something a little more complex than add, minus, multiply or divide. It's a core module that we can import that includes a lot of mathematical functions and extras for us. It'll unlock some of the higher functions such as sine, cosine and tan. as well as factorial and some consonants such as, some constants such as pi and e. And some helpful functions such as fsum, which will add up an entire list for us easily. So before, where we went through for variable in list and then went through and added them up, we could do that. That would, take quite a bit of space and quite a bit of processing. Instead, we can just use an fsum if we're adding a list together. We can simply do import math as it's a core function, so we don't need to do the from math import this like we do with time delta. We can just do import math. Seal and, well, it's actually sealing. For some reason it's just seal in Python. And floor can be used to get the lowest and highest integer for rounding up and down. So if you have 39.9 and you run sealing, you'll get an integer of 40. If you run floor, you'll get 39, even though it's 39.9. If you just need the closest, you can just use round. It's basically just round. You don't need math for this. So a little bit more. In the exam, you'll be expected to use math at a decent level. I'd say, well, in the UK, it's secondary school level. Where you guys are, it's like 14 to 16 level. You may be asked how you would calculate the circumference of a circle and given a couple of options. Some functions such as POW can be used in other ways too. So for example, x multiply y would do x to the power of y, but you can also use POW and then send in x and y as parameters there. Square root is simply square root, but may also be asked about in the exam. Remember, you can use dir math to get all the functions in the math module. So a little more about OS as well. OS is a higher level module for systems on the operating system level. So what this means is almost every major OS is supported by the OS module and by Python itself. So it basically provides a unified way to do things without having to do OS specific stuff. For example, if you want to make a directory, you might need to do that in a different way on Windows to how you would do it on Linux and how you do it on Solaris. The OS module allows you to just call one thing and do it no matter where you are. This helps with cross compatibility so you can have your Python code run on any system. The reason this module exists, as I say, is because making a directory in Linux and Windows is quite different. OS takes away that complexity and will allow you to simply call os.makedir, and then you let the OS and the OS module handle it. The exam can ask about anything under OS, including functions that not even seasoned Python devs would actually know. So makeDirs is actually a directory tree, as in if you're trying to make C, name and Emily, and C and name don't exist, it will actually create those two directories. And as I say, it recursively creates the directories for you. Look out for the keywords directory tree. That's what this exam generally throws at you. You could just use os.makedir if the initial directories existed, and it doesn't actually tell you if they exist or not. It just says make this directory tree. So it might ask you in a roundabout way for that, and that's what you've got to look out for. So a little about sys as well. The sys module basically gives us information about our current Python environment. The most used thing in sys is sys.argv. It's a list of given arguments to Python, basically. Sys.argv0 is always the name of the program. So if you want to know the program you're running under, you can just run sys.argv0 and it will tell you. This allows us to know if we're running directly or running in a module. Sys.argv1 is the next argument. So if we, for example, have a program that needs arguments of names, then sys.argv1 would be the first name. You can do a for args in sys.argv, and this will get you all the arguments underneath under args. So then you can make a new list with the arguments, or do what you need to do with the arguments and give them back to the user. std in, std out, and std error can also be used under sys. Perhaps to write to files, if you want to write std out straight to a file instead of to the user, as in redirect std out, you can do that within sys as well. It stands for standard in, standard out, and standard error, and basically the things that you input and output and get from the program. So standard in is usually you type it in, you can actually get it directly from a file and then put it in that way. Basically, it's quite a common Linux concept. Just if you guys are confused on this, just Google std in for Linux and you'll see what I mean. So a little bit about random, and this is kind of related to math, I suppose. Importing random will allow you to generate random numbers. By default, it will generate you a number between 0 and 1 with about 18 decimal places. Obviously, you don't often need all the decimal places. So if you need a number between 1 and 10, you can just times it by 10 and then use a math.floor or a round or whatever at that point. Math.floor, as I say, can round... Oh, okay, math.floor only rounds down, sorry. Math.seal will round up. Or you can also format for the print like we went through a few modules ago. Okay, some other tips for you guys for the exam as well. As usual, the exam may try to trick you by giving you 20 lines of code, but actually only want you to look at a few of them. For example, sometimes it'll have an import at the top, but it'll actually just need you to recognize that to get a set, you need two inputs to be a set. So, for example, if you have a set and it's actually a list plus a list, this won't work. This will not give you a set. It'll actually give you another list, obviously. So, for example, to get a proper set, you need to make sure the set around the lists, and then that will work just fine. And it'll have import math at the top, and it'll be doing something with math at the bottom. But actually, all you need to care about is this little bit. I've seen this question, and it was tricky, to say the least. The code will have an import to trick you into thinking you need to look at this, when in fact you can just ignore it, and you just need to focus on that little bit of code there. Okay, thank you guys for watching that, and I will see you in the next lesson where we will be going through some final exam tips. And then that's it. Thank you. Bye-bye. Hi everyone, and welcome to Chapter 6, Lesson 3. This is going to be the final lesson. I just wanted to go through some final exam tips with you guys. So in the last lesson we obviously went through the modules that this exam will want you to import and play with. And that was fine. So let's go through some final exam tips and then we're done. So you can probably split the exam up into two parts, let's say. The first part being modules 1 to 4, which is basic Python, variables, types, iterators, all that sort of good stuff, you know, loops, ifs, elses, and this stuff, it doesn't really change. It's in Python, it's there, and once you understand it, you can see it used in other places, and it's fine. Input and output, again, all the same. The only thing that we've added to this is the sys, std in and std out stuff in module 6. Documentation, if you guys remember that, we went through that with PyDoc. It'll only ask you to use PyDoc, the exam. It's not going to ask you to use some of the more modern and better formats, which is a bit of a shame. But yeah, if you guys understand PyDoc, you're good. The second part of the exam will obviously be modules 5 and 6, which are a little bit more open-ended, especially with the troubleshooting. You know, it'll try and make you find something wrong in code, and there'll just be a bracket missing somewhere. So you've got to kind of identify, you know, modules 1 to 4 first. You've got to be able to identify a loop, an if, an else, the types of data that you need, and you've got to follow that through and then figure out where the error is, basically. And module 6 was obviously more about extending Python than anything else. So a few more tips for you guys as well. Unfortunately, the exam is mostly or all about memorization. In real life we would just Google it, but unfortunately, you know, in that exam room you guys are not going to have that privilege. So it's important for you guys to remember mostly the functions and methods that come with some of the modules that we'll be using in Python, and some of the functions and methods that are built into Python, such as round, and some of the keywords if, in, else, elif. You'll have to remember all this from your head, and for me especially elif can be quite difficult. I sometimes use else if. Sorry. I sometimes use else if, which is wrong in Python and will throw an error. My advice for you would be to get the modules we went through in the last lesson, run dir on them and see what's available. But my more general advice would be to keep going through the videos and definitely try to create your own code, look at other code, see where what I've explained to you comes in handy over there, and over time, oh shit, over time you'll get into using the code and where everything should be and how it should be. It's a bit like learning to drive versus actually driving, unfortunately. So the exam does actually recommend 100 hours of Python to pass, and that's practical Python. Whether you guys can pass with less or more is up to you. Just you know, go for the practice exam. We have some practice exams after this as well, and if you feel confident, then try to go for the actual one. There is a PDF that covers everything in some small detail, and that is right here. Hang on, no, that's very small. And this is mostly what I've been using to teach as well. As you can see, candidates for this exam should be able to recognise and write correct Python code, recognise data types, and be able to recognise Python code that will solve a given problem. So as you can see, we do have the skills measured, 20 to 25% here, evaluating expressions, performing data and data type operations. And this is where we add a string to a string, for example, and we get, if a string of 5 and another string of 5 and we add them together, we actually get 55 rather than 10. And this is the kind of thing the exam will try and trick you out on and want you to look at and identify. We've also got assignment, comparison, equals or not equal to, logical, and then is and in. For example, for item in list. We've also got, if, elif, else, and then nested and compound. So as I say, nested is just if. You have if over and over again until you get really far down. Compound is basically putting an and or an or there, which I believe we went through. While, for, break, continue, pass, all that fun stuff there. And then we've got the input and output, output to files or input from console, and again std out and std in. Document and structuring. Solving complex problems, and again you can get this by simply googling MS98381, and it's right here on the Microsoft documents. It should be somewhere down here for you guys. There you go, skills outline. Always think about it before you answer. Sometimes the obvious answer is actually wrong. Just to let you guys know that. That one didn't. It's okay. The exam itself won't be split into nice modules like we've done here. So, we went through modules 1 to 6. Again, the exams at the end will kind of combine them for you as well. They'll generally give you 2 modules at once. For example, a list and troubleshooting it with module 5, or an if and an else, manipulating lists and doing math at the same time. Okay, thank you guys for watching that. And I hope you are now feel more prepared for MS 98381. Good luck and goodbye.